The major disadvantages of this is like as we discussed, the time taken to complete the automation execution, it keeps on increasing with the respect to the addition of the new test cases. So which means whenever the coverage in the automation increases, it obviously increase the time taken to complete it, because of which the feedback loop from the automation regression is getting delayed. TestNg provides the option to run the test cases in three different parallel way. One is a test, another one is a classes, another one is a method, test methods, which means here we have to define the number of threads the test cases have to execute, and that's it. Whenever we load the Jenkins with the multiple threads, first it will completely occupy the first machine, then it will move to the second machine. We have to configure our router and then the nodes. So configuring the nodes and the router will be taken with the help of the distributor. So the nodes will send the registration event to the distributor via event bus. So whenever the distribution receives the event, so it will send back the HTTP request to make sure that the nodes are still available. One more biggest challenges of moving to Selenium Grid is, so before Selenium Grid, we have our parallelization with as a Jenkins jobs. So each job started as a separate processes. After moving to Selenium Grid, it's a single process where we are creating a multiple threads.
I would like to welcome all of you to the 16 virtual meetup with Habeeb Muhammad. So before that, a huge shout out to Browser Stack, who is our exclusive sponsor for all community events and premier sponsor for all conferences. Without their help, we wouldn't be able to do so many events to help you upskill yourself. So now I would like to call our next speaker on the stage, Habeeb Muhammad, and a little bit about him. Um, so Habib is a SDET with over 8 years of experience in the field of software testing. He has hands-on experience in variety of testing tools and frameworks. Currently, he's working at CX Automation Startup. I would like to invite Habib on the stage to take his session. Hi,
Hi,
Habib.
Deepika. Hi. Am I audible?
Yes, you're audible. Yeah. Hi. You
Hi,
can
Vanshika.
now take over the session and talk about your topic on Selenium Grid.
Yeah. Thank you, Anshika. Thank you for the intro. Just give me a second. First of all, I would like to thank Vanshika and Test Drive for this opportunity. And yeah, and also I would like to thank Gunesh, who is guiding me throughout this. Since this is my first ever webinar, and guiding me through this to make this happen. Thank you, Gunesh, if you are here. Yeah. So before moving to the presentation, even though Vanshika introduced me, I'll just introduce myself. So my name, as everybody knows, like my name is Habib Mohammed, and I have total of 8 years into testing. So throughout my testing career, I have worked with various tools and various testing techniques and testing types. And currently, I'm working as a lead asset at Azure. Where, uh, yeah, where Azure is a AI-powered no-code platform tool, which is used to experience the customer automation. Yeah. And majorly, I am working here as automation, identifies the areas of improvement for automation, and working with the team to drive the solution to it. So this is my roles here currently at the Azure. Yeah. Before moving into the slide, I would just like to put some context about what I'm going to talk and what are the key takeaways we can get from this presentation. So, by the name suggests Gridify, so I'm not going to talk here about what is Selenium, like even though I touch very basic points on Selenium Grid and how the flow happens, but I'll not deep dive into any of our testing concepts like testing frameworks, even not into Selenium Grid. But instead, I would like to take everyone through a journey which we went through to scale our automation framework, which helps us to reduce the automation execution time of 3,500 test cases from more than 7 hours under 2 hours. So yeah, this is the context of this entire presentation. So I'll make sure, even though this is my first ever webinar, I will make sure that I will try to put some idea about how we can scale our framework as a step-by-step process to a point where it can scale automatically with very minimal changes. Yeah. Now let's get started. Yeah. So most of us might have automated few test cases in our daily life, and one of the major concerns with the respect to automation, what most of the people face is, so our automation looks fine when the number of test cases are very minimal, so that when the test cases are very minimal, the time taken to execute the test cases also will be very less. But at a point of time when our automation framework increases, grows, and the number of test cases grows, the time taken to complete the automation execution is going to be the tedious process. So let's try to understand with this simple tabular column. So I have taken an average time of a UAT cases is 30 seconds. I know that in a real world scenario, none of the UAT test cases will execute under 30 seconds. But let's go with an example. So initially, let's consider there are 10 test cases with the average time of 30 seconds. So it completes under 5 minutes. It's great, right? But when it gradually increases, the number of test cases increases, we can see that time also increases, but at some point of time we can see it just increases in an exponential way. Like when it reaches 500 test cases, it almost taking 4 hours and 8 minutes. When it reaches 1,000 test cases, it's almost taking 8 hours 20 minutes. But in the real world scenarios, let's consider if we have a like most of our UA test cases will run around minimum 2 minutes. And I have experienced few test cases are there, like few suits in our, even this company has runs around more than 9 minutes, 10 minutes based on their functionalities capabilities. So it reaches beyond the stage where the entire regression can run for more than a day. I heard from the people saying that their regression suits run more than a day. So the major disadvantages of this is, like as we discussed, the time taken to complete the automation execution, it keeps on increasing with the respect to the addition of the new test cases. So which means whenever the coverage in the automation increases, it obviously increase the time taken to complete it. Because of which the feedback loop from the automation regression is getting delayed. So because of which, when after the as we all know that after the regression completes, we have to do the report analysis to figure out is there any open issues, or there is there any new issues we have found. So even the execution takes 1 hour, 1 day. Then the report analysis will take another hour or two, which in turn ultimately delays the releases of the product, which is not a good sign for any growing company, or even the company which has been already grown as in this agile environment. So let's understand how we can able to solve this issue with the help of parallelizing our test cases. So I have taken one example, like I have taken the previous example itself, but this time I have just tried to run my test cases in the parallel mode. So here I am trying to increase my number of threads based on the number of test cases gets increased. So here, if you see, like when the minimal test case, sorry, yeah, it's just 10 seconds, and I was running them in under with the two threads, so I could be able to complete the test case under 2 minutes 30 seconds, which was running 5 minutes here, earlier. Similarly, if we take the test cases which was running like 1,000 test cases which was running for 8 hours and 20 minutes, it was completing under 10 minutes. But it's not a real-time example, right? Let's take on real-time example where the same 1,000 test cases with the average time of 120 seconds, which was executing 33 hours in a linear execution previously, was completing under 40 minutes. Even though it didn't look real, right? Where 1 day regression is completing under 40 minutes, it's a real time, it's a real one. So this is what uh, we achieved in our journey, and I would like to take everyone through through this journey. And what are, like, in this journey I'll be mostly touching few points on the uh, different types of parallelization ideas, and mostly on the how we can harness the Selenium Grid and achieve this very scalable framework, so that at a point of time we don't want to do anything. Just in case of number of coverages gets increased, we just have to increase our threads, and all the activity will be taken care by the Selenium Grid itself. Yeah. Let's discuss few ideas using which we can achieve this parallelization. So thus helps in understanding how Selenium Grid stands in a way better than the other parallelization ideas. Okay, let's talk about few testing frameworks. So in our daily life, we would have worked on either one of the framework like TestNg or BDD, any other testing framework like nowadays Cypress, Playwright. These frameworks are available in the market, and we might have worked on any one of the framework for sure, right? So here I'm going to just give an idea about how we can achieve parallelization using TestNg. Simple ideas follows in the other framework as well. So here just I'm going to touch upon the point. So using the TestNg, achieving the parallelization is very simple. So TestNg itself coming up with its internal capability for the multi-threading. So we just have to define a XML where we have to define the parallel type in which we are going to run the test cases. So TestNg provides the option to run the test cases in three different parallel way. One is a test, another one is a classes, another one is a method, test methods, which means here we have to define the number of threads the test cases have to execute, and that's it. So TestNg will take care of all the other needed things. So advantages of having this way is it's easy to implement. It's just an XML creation and the configuration of parallel types and number of parallel threads, and even multi-browser supporting also is easy. Like we just have to define our driver factory in such a fashion, so the multi-browser support also we can take care of. But the disadvantage of having this kind of parallelization is the entire execution using this TestNG framework will happen in the entire machine, single machine. So because of it, like in a day-to-day life, if we take any normal machine, we come up with a kind of a 16 GB machine with a 8 core threads, which is capable of, if I'm not wrong, handling 10 threads or 12 threads. So let's consider the in the previous example which we discussed, when we want to scale to 50 threads or 100 threads even in the future. Just think of the machine size, how huge it will be. So this kind of parallelization is not really the good way of parallelization. And one more thing is a multi-platform testing. Suppose anybody want to do testing on the Windows, Linux, or even on the Mac OSs, it's not possible using that. We have to separately set, we have to separately trigger our framework in different machines. That's not a good idea, really. Yeah. Then we can achieve parallelization using the Jenkins. As we all know that Jenkins is an automation server tool to support, build, deploy, and automating any kind of projects. So in Jenkins, so the problem which we faced on the using TestNG XML is distribution is not possible, right? In Jenkins, we can achieve it by connecting multiple nodes to the Jenkins master. So all we have to do is configure few jobs. Basically we will be just creating one freestyle job, which is main purpose is to build the automation project, and second job is a kind of pipeline job which uses this child job, a freestyle job, to distribute the test. That's using these two jobs we can able to achieve the parallelization. But yeah, let's discuss the advantage of. So the test execution happening here is a distributed setup. So we can run our test cases in n number of platforms, and with the n number of browsers. But the major disadvantage of having Jenkins parallelization is, even though we say distribution is happening here, it's not the actual distribution. Let's consider an example like, let's take a ticket counter which have a 5 rows. So when we say it's a completely parallelized, so each rows has to be occupied parallelly. Like it's not like we fill one row completely and then moving to the next row. It's not the actual distribution, right? But that's what happened with the Jenkins. Whenever we load the Jenkins with the multiple threads, first it will completely occupy the first machine, then it will move to the second machine. So thus in turn, sometimes it overload the particular machine, which might end up in uh, yeah, which might end up in having some memory leakages. And so by to having the, and also to utilize the better time efficiency from the Jenkins parallelization, we have to calculate the time taken to complete the test cases in the each machines, and then based on which we have to distribute the test on all the other machines available. This is a tedious job when it comes to when our test coverages increases and the number of test cases increases. And yeah, and also whenever this multi-threading is started with the Jenkins, each parallel thread will be started as a separate process. Since all we know, each process will spike up the memory at the starting point of time, and it will consume a good amount of memory. So really it's not a good way. So so then what approach we have? Here comes, yeah, here comes the Selenium Grid. So the disadvantages, whatever we have talked on the using testing framework and Jenkins parallelization, using Selenium Grid, we could be able to overcome this issue. But it's not. But I'm not saying that Selenium Grid is a standalone thing where we can eliminate testing framework parallelization or Jenkins parallelization, and we can purely rely on the Selenium Grid. But we can use the like, but still we have to use the support from testing framework and Jenkins to create the pipeline script, on top of which we can use our Selenium Grid to parallelize to distribute the load. So in simple terms, if I want to put what is Selenium Grid is, it is a kind of it is a kind of a client server architecture. uh, it's a architecture where it acts as a load balancer distribution, which provides an easy way to run our test cases in multiple machines, and also it allows testing on the different browser versions, as well as it enables the cross-platform testing. So, what are all the disadvantages we have discussed using in the previous approaches? We could be able to overcome with the help of Selenium. So yeah, so whenever we are going to talk about Selenium Grid, the implementation phases in the upcoming slides, we are purely going to talk on the Selenium Grid 4. So we will never touch upon the previous versions. What are the Selenium Grid 4 advantages it have, how it differs from previous versions. We are not going to touch upon any of the points. So why? Because the Selenium Grid is currently live, and its current architecture is revamped, and it has a very good performance comparing to the previous versions, and also it has compliance with the WP standards now. And moreover, so now Selenium Grid comes up with the cloud distributed scalability as well as the containerization capability. Yeah, these are the main reasons why we'll be working with the Selenium Grid for. Yeah. So let's understand the Selenium Grid architecture first. Even though we will not use them as a separate components anyway in our upcoming slides or even in our journey, but understanding these components is very much important, so that at any point of time, if you want to debug, if you want to trace back any issues, it's very useful. And also in case if we want to do our own completely distributed Selenium Grid setup, understanding these components is very, very important. Yeah, let's discuss that. Yeah. Once again. Yeah. So whenever the router receives in a test case command from the client, so the router, yeah, before the router gets any instructions, so like we have to configure our router and then the nodes. So configuring the nodes and the router will be taken with the help of the distributor. So the nodes will send the registration event to the distributor via event bus. So whenever the distribution receives the event, so it will send back the HTTP request to make sure that the nodes are still available. So once it get back the response, so the distributor will register the nodes to it, and it will the distributor will keep track of all the nodes informations as well as their capabilities such as what kind of platform the nodes are and what are the types of browser versions it can support. So all that information's distributor will keep track of it. Okay. Now let's see, like whenever the router receives the request, there are two kinds of requests the router may receive. One is a new session request, another one is the existing session request. So when the router receives the new session request, it will send the information to the request to the session queue. So the session queue is a kind of a queue approach, as the name suggests. So it will add the new session queue to the queue to it. So the distributor will keep polling the session queue for if there is any new session request is pending. So whenever the distributor finds the new session queue, so it will try to find the corresponding nodes available. So whenever any new nodes available, the distributor will create a session and send back the information back to the queue, says that the session has been created, and the information will be sent back to the router. Asynchronously, there will be one more call happening. So whenever the distributor creates the session, so the distributor will send the one more information back to the session mode, saying that and sends the nodes and its sessions information back to the session map. Session map will keep track of all the nodes and their session informations. Yeah, when the router receives, like now we saw the new session request uh, flows, how it happens. So whenever the router receives the existing session map request, the router will send the request to the session map and queries them. So whenever there is a matching query for the existing session request, the information will be sent back to the router. So either it is a new session request, or either it is a session like existing session request. The router identifies the node first, and then once it is done, the router sends the information directly to the node, and the node is nothing but they are just the machines, and their purpose is only to execute the commands whichever it receives from the router. So once it executes the command, it sends back the response back to the router, and the router sends back the information to the client, says that the action has been completed, and the client acknowledges them and then send the other request. That's how the information flow or the request flow will happen between the client and the Selenium grid. So this event bus is nothing but, since we all know that the HTTP calls are costly and it's a time-consuming process, all the internal asynchronous communications are happening through messages, which is taken care by this event buses. Yeah. Yeah, so we saw the architecture, but if we want to understand the Selenium grid in a very simplified manner, like there will be a hub and node where the hub receives the instructions from the test scripts, and the informations that test scripts carries. Based on the information that test scripts carries, hub identifies the nodes, and it will execute the commands on the particular node and sends back the information to the hub itself. Yeah, to this is the simple understanding of Selenium grid. Yes. Yeah, then we can start the Selenium grid in multiple modes. Yeah, sorry. There are like a standalone mode, hub and node, fully distributed, and Dockerization mode. In these presentations, we will not walk through on fully distributed or Dockerization mode. Instead, we will be going through our journey on POCs with the Selenium grid standalone and the transitions to hub and node mode, and how it helps us to scale our automation framework. Yeah. So in our implementation phases, there are two kind of changes, or I could say two kind of improvements went head to head. So there is a infra level changes or improvements, and whenever we are going to infra level changes, parallelly we will be doing the framework level changes also to adapt to this infra level changes. So yeah, all the implementation phases have these two kind of changes. So let's start with the phase one. So very first phase is to make sure that our framework, when we say why we want to do this, our framework is not like we didn't build it from the scratch, but there was a framework available with us. which has already 3000 plus cases, 2800 plus cases. So we want to make sure that uh, our exist like we don't want to move to new framework, because building up all these test cases from the scratch is going to cost us very huge time. And yeah, and we have to make sure that we have to do some kind of scalability to the existing framework. So we have started with the standalone mode POC. So for any Selenium Grid mode, we need two prerequisites. One is the drivers, browser drivers. Another one is the Selenium Grid jars. So in this POC, we just went with the Chrome driver. So we can download the Chrome driver from their websites. Even the Selenium Grid also we can download from their websites. Yeah. So we just have to place them in a particular location, and we have to start. We can start the Selenium Grid in a standalone mode using the simple command. So when the Selenium Grids try to start the when the Selenium is try to start, so it will try to automatically detect the drivers available in the machines, and also it will try to detect how many number of virtual processes the machine capability has, and it will assign those number of browser session to the particular machine or node, I could say. Yeah, and as I mentioned, we had to do few framework changes, and it's very minimal. So initially there were a Chrome driver initialization, and just we have to move it to the remote driver initialization. So this is the simple change we have to do, where we in the new remote web driver initialization, we have to pass the URL of the Selenium Grid. So it's not mandatory to use only the local host. Selenium Grid 4 comes up with the capability where we can configure our hub in a separate machine as a different service overall, and we just have to pass the URL. This is how most of our automation tools, scalable tools which are available in the market works. Though they will configure the hub in the different machine, and we will be just passing the URL. So here we can see once the Selenium grid started, we like if we try to access the local host, we can see these informations, right? Like it says that how many number of maximum Chrome, Firefox, Internet Explorer, Edge it can support, and what is the maximum concurrency of these machines. Yeah. Yeah. So after making these changes, when we tried to execute, then the execution went through successfully without any issue. So yeah. So next step, as a part of the phase one, we have to execute our test cases in a parallel approach, because as we discussed, the linear approach is not going to scalable. The main agenda or idea of this is to make them scalable. We have to, as a next step, we have to run our test cases in a parallel mode. So we build already built our framework with TestNg. So we thought of going with the TestNg parallelization approach itself. Like as I mentioned earlier, even to work with the Selenium Grid, we need few supports from our testing framework as well as Jenkins. So here, how to how to run our test cases parallelly, we have to define them within the TestNg XML itself. Yeah, so we went with we have chosen our test approach as a mode to execute our test cases. Why? Because our application is like the way the automation framework built, which is not able to support the execute the test cases using the class level parallel approach or test method level approach, because we our application has few external dependency, like since it is a customer experience automation platform, right? We'll dependent on few external factors like SMS messages, emails, and other lot of stuffs. So those for those stuffs, we cannot run entire test cases or run with the classes level, methods level, because these SMSs, outgoings, incomings, or emails are all has some cost factors associated to it. So we went with these test approaches. So what we did is we have grouped similar functionality of test method, test classes under one test category, and then we have created a XML with the identified set of subsets. So here, one thing what we did is we didn't went with the variety of test approaches. Why? Because as we have like went through the automation framework, there will be few set of test cases which needs a few classes implementation, which deals in the different way, and few classes might be goes with other way. So we have identified pure UI cases where we are not going to interact with any other external APIs like Twilio or other stuffs. And we have identified purely internal cases and went with this parallelization approach to make sure that we could be able to achieve the parallelization on initial phases. Yeah, after making this, how to make like as we discussed in the earlier step, after making the Chrome driver initialization, it started working, but here it will not work because here it is going to run in parallel. So for each parallel test, we need a separate browser session. If we create a single browser session and share it to, across all the different tests, it's not going to work, right? So we need a new driver object for the every session. So how we created is with the help of TestNg again. So there was a test listener available in the TestNg. So on before each test start, before each test start, we created a new driver object and stored it in the thread local variables, and we use the same thread local variable to access the browser sessions informations. Yeah. Yeah. So now after making all these changes, we have achieved what we thought. Like we could be able to run the identified subset of tests parallelly without any issue. Parallelization was successful. Yeah. Yeah. Next phase. Next phase is moving to Hubbard node setup. Why we have to move to Hubbard node setup is again the reason is the scalability. If we remember the point which we discussed on the testing framework is the all the even though we could be able to parallelize our test cases, all the parallelization happens within the all the parallelization happens within the same machines. This is the same issue which we faced with the standalone mode also. So for that purpose, since it is not scalable and it is not distributed, so we move to the Hubbard node setup. Yeah. So here to move to Hub and Node setup, we have used two different machines. We went with the cloud scalability is cloud machines since Selenium Grid supports cloud cloud execution as well. So we have provisioned two AWS machines with the help of our DevOps teams. So one is for Hub and another one is for Node. So then we try to establish connectivity between the Hub and Node because as we know that hub receives the commands and it sends to the node, whereas this node executes the commands and sends back the response to the hub. Status of the request. Yeah. So we have started the hub using this command. Yeah, and it is successful. We could be able to start the hub. But when we try to start the node using this previous command, but it failed. Yeah, there were multiple reasons behind that. The first issue what we faced is the machines are not in the same VPC. So when we requested the machines, they have created the machine hub and node in the different VPCs, because of which we couldn't be able to establish the connections. So we identified that issue and moved both the machines under the single VPC. But then again, when we try to connect it back, it's not allowed because the ports, whichever is mandatory port for Selenium Grid to work. Like as we discussed the different components in the Selenium Grid in the previous slides, each component is a kind of a process, and each process starts on the different nodes. So as we discussed, there will be multiple asynchronous calls. Will be there. There will be two kinds of asynchronous calls. One is a publish events and receive events. All these events will be happening on these nodes. Double four to triple four to triple four three triple four four, and nodes will be listening on the double five port. So we have to allow these ports between the hub and node. So how can we allow? We just have to create a security group in our AWS console, and we just add it to both the hub and node missions. And yeah, now we thought we could able to connect the or establish the connection successfully, but then again we failed. So then we figured out, like we tried debugging, and after a lot of debugging, we figured out that since they are the Windows machines, right, it has a firewall sometimes like mostly helps us, sometimes blocks us as well. So this time it blocked us. So now we have added our inbound roles to allow this port between the machines. So once we did all these changes, now the connection was successful. Yeah. Then yeah. So as I mentioned, each implementation phases has two kind of changes which has to go head to head. So now this is the time for framework changes for phase two. Framework changes nothing but the same kind of framework changes which we went for phase one. So we have created a TestNg XML, but this time, yeah, large XML with the multiple tests. But this time, like last time, we have identified a similar set of tests, but this time we went with the variety of tests, and then we have added a multi-browser support to the framework. So how we can do is we can have our driver factory where we based on the input parameter either we want a Firefox or either we want a Chrome. So we can create the browser instance based on that, and then the constants for that. So this one again, it's not like I could not guarantee that everyone will face this kind of issue, but I can assure that few applications will comes to the like will may face this kind of issue. What is that is sometimes there will be a crunch we might have to face due to the other cost factors associated to our application. So as I mentioned, we have few cost factors based on the number of messages to the we send from our application and we receive from the application. So we use a Twilio for that, and as consider like it's almost 2,800 test cases, and we were sending around 7,000, 8,000 messages per executions. And each time provisioning each trillion number also has a cost associated to it. So it's not like we can directly go and purchase some 200 numbers and kept with us, because even though we are not going to have those much of threads, there will be some cost associated to the purchases, and we have to simply pay to the external vendors. So in that case, we have to trade between the cost and then the threads and the external resources. So for such purposes, we have come up with our own thread property manager. So the main purpose of the thread property manager is it will read and initialize the properties from the JSON file, and it will assign the properties based on the each test level, how we assign the browser sessions. And whenever particular test case completed and whenever the new test cases comes in, so this third property manager knows which property or which test has been completed, and it will fetch the properties from that particular test and assign it to the new test coming in. So that's what the requirement of this third property manager. Yeah. And then, so one more biggest challenges of moving to Selenium Grid is, so before Selenium Grid, we have our parallelization with as a Jenkins jobs. So each job started as a separate processes. So for that, we don't need to worry on these variables, how we access the variables, how we retrieve the variables, objects creation, those parts. But after moving to Selenium Grid, it's a single process which where we are creating a multiple threads. So we faced a lot of concurrency issues, memory issues when we trying to implement when we trying to move to the Selenium Grid, the hub and node concept. So for that purpose, we have to do the framework optimization. So this framework optimization is nothing but some good practices we have followed to make sure that our automation framework is up to the mark, and we are not going to face any kind of memory issues or other concurrency issues. So we have to make small changes. It's a kind of not a small, it's a big changes we went through in this phase, and in this phase we have just a simplified ingredient. Like in our automation framework, there are multiple inheritance were there, and when we are about to separate the inheritance and the classes, it becomes very tedious because it was multi-level inheritance we actually created, and removing one inheritance caused errors around minimal hundreds of classes. So we simplified all the inheritance, and all the utilities we have moved all the utilities classes to singleton, since we no need to create multiple objects for any of the utility methods or other stuff. And we have moved all the test data related methods or variables to static variables. And yeah, we have decoupled few classes to create the object creation. So this comes again in hand with the simplified inheritance. And also there is one more things which most of us misses is, so we just simply go and create the object class level objects for each whichever we need on the instance level itself for all the test cases. So by doing that, what it happens is it will actually increases the time for building the project itself. So to reduce the time for building the project, we have moved all our initialization to the before class or before method based on the requirements, and we moved to thread local variables instead of instance level variables to avoid the concurrency issues. These are the few framework optimization we went in. Yeah, after making these changes and identify after making these changes and creating a few TestNg XML with a few subset of tests with a variety of functionalities, we could be able to successfully achieve run the automation in the distributed setup. Yeah. Then what is next? So this time, this is the time for infrastructure enhancement, right? We cannot have only one machines and run our execution for a longer time. Previously itself it was running around 8 hours, but when we reduce it to two machines, it may run for 16 hours. May so. So now it's a time for infrastructure enhancement. So this time, instead of one node, we have added the four machines for nodes, and we have moved our configuration details to TOML files. TOML files are nothing but it's a simple configuration file with a simplified synaptics, easy to read. So Selenium Grid comes with that capability to configure the informations about the nodes, browser sessions, etc. So yeah, why? Because when these configurations keeps on increasing, so then the using these configurations on the CLI options level is will be very big, and it's not flexible though. And yeah, every time if you want to restart the machine and restart the node back again, connect the node back again, you have to pass that very huge CLI option to connect to it. So to make it simple, we have moved to TOML files. Yeah, after moving them, we just started our node by using the commands which we discussed earlier. Yeah. So let's understand. I'll try to explain the sample files which we are using, and we are not using all the configuration options, but we have chosen few configurations options which we need. So the first one is a node, and there will be two sets. One is a node, and second is a node driver configuration. This node configuration is for the machine level configuration, and this node driver configurations are for the driver level configurations. So direct driver equal to false means, as I have shown in the earlier slide, when we try to start the node, it will try to detect all the possible drivers available, and it will start all the it will associate all the browser sessions. But sometimes in a particular machine we just want a Chrome or Firefox. In some machine we just need a Safari. So in such cases we can just detect driver set driver equal to false, and then session time equal to 1500. So session time in some cases, right? Selenium has this default configuration of 5 minutes, where if the hub or node doesn't receives any request within that 5 minutes, it will kill the session. So in some scenarios which we have to wait for like kind of a email for uploading the files. Such cases we have to wait for a longer time, because the files which we are going to upload is a huge one, and it will take some 10 minutes, 15 minutes of time. So in such cases we have to make sure that session is live during those times. So we have configured this session time mode. It's in seconds, so which is 25 minutes. And override maximum session equal to true is nothing but so Selenium Grid by default try to identify the number of virtual processor and assigns the session browser session to it. But in case if you want to reduce or if you want to increase, so one good thing about Selenium Grid is, like, even though it assigns a number of browser session equal to the virtual processor, we have the privileges to increase or reduce the maximum session. So we can override it. For example, uh, uh, the recommended uh, the recommended number of browser session is always equal to the number of virtual process. But all the machines has a capability to at least support the browser session equal to 2 into number of virtual processors. We have even done that. We have even proved that, and sometimes it could be able to even save the cost of provisioning multiple machines. The maximum session here is to configure how many maximum session can this node can launch at a time. And when we move to node driver configurations, so we just giving the name to this driver and stereotype. Stereotype is very important. because here only we will configure the capabilities of the machines. So using these capabilities only, our driver scripts can identify the machines in case if we have few scenarios which for which we have to run our test cases in the particular machines. For example, we had a few scenarios like a kind of SFTP scenarios where we have to do file transfer through SFTP protocol, and this SFTP protocol is enabled in only few machines, not on all the machines. So for that, we configured this stereotype, and we have passed these informations on our driver capabilities, using which our script can identify the machine and execute the scripts over there. Yeah. And downloading files, yeah, you may feel this comes out of a context, but still, like, I would like to explain this because we have few scenarios around the files uploading, downloading, verifying them. So before Selenium 4.7.2, if I remember rightly, there were no options for verifying the downloaded files, and we had to do few modifications. Like, it's a very tedious process about how we have downloaded the files and verified it. And also, while in this transformation phase, we put it on a hold because we couldn't able to find a solution. But after some point of time, when the Selenium Grid 4.7.2 comes in, it comes up with this capability, like where we have to just pass this enable manage download equal to true on the node section, and we have to pass this capability in the driver options. That's it. Like Selenium Grid gives the two set of APIs. One is a get API to list all the files downloaded for the particular session, and the second one is to retrieve the files from the particular session. We just have to pass the session ID and the file name to it. That's like you can get the files downloaded from the particular session to your hub machine, and we can do anything we want. Yeah. Okay. After making these changes, so what we achieved is, so we have increased our threads. Like previously, it was 12 threads. Before Selenium Grid, we were using this Jenkins level parallelization. As I mentioned, we have our own disadvantage of using that, where each time we have to modify our pipeline scripts, and whenever any new test cases is being added, somebody has to make sure that it is being going into the pipeline. If not, lot of times we miss the test, and after some point of time we realize, oh, we missed it, and then we have added it. And also the distribution, as I mentioned, we have to calculate the time taken for each node, and based on which node is taking the lesser time to execute, that we have to add our new set of test cases. It was a very tedious process, to frankly say. Like as we are doing automation to remove the redundancy, we end up in doing a lot of redundancy on the Jenkins pipeline script level. So that's why we moved majorly to Selenium Grid. So after making all these changes, so we could able to achieve we can able to increase our threads from 12 to 23 threads by just connecting those in the four new machines and doing that infra changes and framework changes. Now what we achieve after this is, our execution time has been reduced half of them, like from 7 hours to 3.5 hours. It reduced. Yeah. So this is a major achievement we did, as we have brought down the execution time from 7 hours to 3.5 hours. Yeah, but still, if we say, is it a well good enough solution? But not, because we have provisioned, like, what are the machines we use? They are Windows machines. As we all know, Windows machine has its own advantages and disadvantages. But for our automation, what we face is these browsers, right? In the Windows machines, whenever we open it up for either for automation or for some debugging purpose, it was getting auto updated, and because of which the drivers whichever we used to connect the hubber node was getting old. And when we tried to execute the execution, since there was a driver and browser version mismatch was there, execution was keep on failing, and sometimes we were facing cache and memory issues within the Windows machines. Even the process gets killed. There were some memories it's being sit on the Windows machines, and sometimes it was causing a heap issue on the. So for that we have to keep on restarting the machine. So to overcome this solution, to overcome the solution, like we have thought of coming up with the two Windows batch scripts. So one is for downloading the drive. So this is a kind of a nightly batch scripts. So on each night it will run. So one batch script is to download the WebDriver manager on all the hub and nodes, like what are the drivers we need using the Bonigashe WebDriver manager on all the hub and nodes. This scripts checks for the browser version and identifies the required browser driver version and downloads them and replace the existing versions. And the second script is to start the hub and connect the nodes to the hub. So by doing all these things, we made sure that on each night our drivers are getting updated with respect to the browser versions and connecting back to the server. Yeah. So yeah, after making these changes, yeah, everything is going well. But there was one scenario is happening in the background where our test cases are keep on increasing and adding it, and the coverages also keep on adding it. And the same time, what happened since we are our number of threads kept on constant, gradually the time taking to execute the test cases is getting increased. Like it was 3.5 hours, but after this phase, there were 700 more test cases gets added, and almost another 1 hour gets added to the execution time. So now comes the requirement from our management team. Since we might have experienced a phase in our company, like where we will be growing rapidly at a certain point of time. So for that, we have to improvise our infrastructures and speed up the processes. So, and there was a requirement for this to the automation team is we have to complete our entire regression under 2 hours, right? So this looks a kind of a huge task in front of us, but here's what the Selenium Grid, what are the learnings we did, helped us to achieve the requirement in a very shorter period of time. Like yeah, so in this phase also there is a requirement like using Windows machine there was some flakiness, because of which we have to fix that flakiness, and it has to be very stable infra and automation frame. That's what the requirement is. So to overcome that, we have identified that moving to Linux could solve this issue, because the Linux has a very good memory management and other stuffs over Windows. So we have moved to Linux, and we have created 8 CentOS machines this time for our nodes. Sorry, one for hub and 7 for nodes, which has capability to handle 66 threads. It's a direct number of threads, but in case if you want to go beyond these threads, as I mentioned, we can override the number of maximum sessions. Even this with the same machines, it can even scale up to 120 threads, but we have kept it simple as the time requirement is just 2 hours. So by this time, as I mentioned, the security suits were coming in, customer related suits were coming in. So everything is added to our frameworks, and then we have to configure the TOML files for all these machines to configure the machine's capabilities and browser sessions, etc. And as we discussed earlier, we have few download file scenarios where we discussed using the Selenium APIs. We can do that, but I could suggest using this Selenium API uh, is a suitable option when we are using with the Windows machine where this mount EFS shared drive is not possible. So, but with the Linux machines, we can mount the shared drive. So we can download these files on the particular shared drive, and we can be able to access the file using the hub machines. Yeah. So one more change is, since they are Linux machines, we have to run our test cases in a header. Yeah. So to do that, we have to pass two arguments. One is headless. So to make sure that since Linux doesn't have any GUI options, we have to run it in headless. And we have to set the screen size. Why this is important is, since Linux doesn't have any GUI, when we try to maximize the screen, it will actually set it to 800 into 600 size only. Because of which there was some elements overlapping happening within the UI. So to overcome this, you can set it to any normal screen UI size. It's not mandatory that you have to set only 1920 into 1080. Any default size we can set. And yeah, after moving this, Yeah, how did we achieve 2 hours execution rate? So consider we have defined multiple set of tests, and if each test is running for 2 hours with only for 23 threads, at some point of time there might be some overlap of test case happens. So at the end of the second hour, some one test might start, and actually that particular test can start delay the overall cycle. And also we have here in this process there is no effective utilization of the 60 threads which we have created. So to utilize the 66 threads, we have broken down our entire TestNg XML test suite into multiple tests, and we made sure that each test is not running more than 30 or 40 minutes. So by doing these changes, so initially when we started with this implementation space, there were only 23 groups, and it eventually went to 108. So and also it helped our developer whenever developer making any changes and they want to make sure that regression running fine, they just have to pick up that particular test and they have to run it. So for that, they can even come up with a solution within 30 to 40 minutes, whether the changes are whether breaking or making breaking or not, instead of waiting for 2 hours if you go with this approach. And also we have added a real-time Slack notification for each test, so that even people who are analyzing the report, they don't want to wait for this entire 2 hours to analyze the reports. Even we have reduced that time as well. Yeah. So yeah, after these changes, what we really achieved is scalability. So in case if in future if we want to move, if our test scripts are increasing from 6,000 cases, the scalability is very easy, where we have to just increase the threads and that's it. We don't want to do anything in the framework level, just infra level, we just have to increase the test. So to make sure that I'm just trying to explain using this table. So initially before Selenium Grid, we had 2,800 test cases within 12 threads, which was running for around 7 hours. But after Selenium Grid phase 2, there are 200 more test cases increased, and number of threads is 23, and execution time is just 3.5 hours. After Selenium Grid phase 3, we had around 3,500 cases with 66 threads, and the execution time is 1.5 hours, which is almost less than 80, just a 20 percentage when comparing when we started before Selenium Grid. And this reduces the feedback loop time for us, and it allows our company to do multiple automation regression for multiple builds and releases. Thus, in turn, fostered our product delivery as well. Yeah, yeah. This is what I would like to share with every one of you how this Selenium Grid helps us to scale our framework. I hope this helps. Yeah, that's all from my side. Thank you, everyone.
Yeah, thank you so much, Habib. Like that was a great presentation. Um, we have few questions, but I think Gunesh had answered them, so I think we can take like one or two of them,
Sure,
and then
sure.
we can probably move to Discord. And if anyone else has any questions, we can do it there, where we can have that networking session plus some question and answers.
Okay.
So I'll take few that have most upvotes. So, how to overcome weight issues while running test cases on Jenkins, as it is fast as comparative to less test cases, or running on local machines and integrated to CI/CD.
Yeah, most of the testing, WebDrivers comes up with the explicit write. So explicit write is the recommended approach, because when we go with the implicit write, it it actually I could say it actually increases the time for the execution. So two things which we can do. One is the implicit write. So to make sure that you are writing only till the element appears or disappears, and then using the try catch. Sometimes there will be some scenarios due to Ajax call issues or other stuff. So the element may appear or disappear before the time. So you can use a try catchable. And also, I could recommend you can check for the Ajax calls in your scripts, like using the JavaScript executor. This really helps even us. So we check the Ajax calls before whether the Ajax calls gets completed or not before we try to access the elements. Once it is completed, we try to. So this is how we overcome our right issues.
Understood. Understood. We have another question from Kiran. I'll just show it on screen. Please throw us some light on pricing information when managing grid by oneself versus using cloud-hosted grids like Stack, etc.
Uh, yeah. So just a minute. Yeah, like when we go with this open source automation tools like Browser Stack or Lambda Test, the pricing was really huge. So as I mentioned, like we initially thought of going for Browser Stack or Lambda Test, but the cost is associated with it. Right? Like now we have 66 threads, and the cost associated to the 66 threads is one second. Yeah. Yeah, it's kind of some $2,500. But when you go to Lambda test other stuff, the cost associated will be like even for 25 threads, you have to pay more than this. So that's why having your own setup, but browser stack Lambda test it has their own advantages of having kind of automate like mobile testing and other stuffs. But still, like if you are purely needed on the infrastructures, and I could recommend to go for a own Selenium Grid setup instead of going for Lambda test on open source tools.
Okay, so thank you for that answer, Habib. We have one more question that we can take from Madhu. What are the benefits to move to Selenium Grid over other tools available such as Browser Stack, etc.?
Yeah, that's all. First thing is cost efficiency. I could say that if you purely dependent on the infra level, and you don't have variety of scenarios like mobile testing and other stuffs, so you can have your own setup. And one more thing is you can have your own control at any point of time. You can reduce, you can increase, you can do a lot of POCs. Yeah.
Understood. I think if there are any other questions, we can take them up on our Discord community. So thank you so much, Habib, for this session. It was an amazing session. I can surely, understand a lot of things. So thank you so much for that. And do join us on our Discord community. Let's continue talking there. So thank you so much, everyone, and have a nice day. Bye.
Thank you, Anshuka. Thank you.